Okay, for those who know a bit advanced math subject, we have a quick integral calculus problem to consider. Can you solve it in 2 minutes? The e is a special irrational number, approximately 2.718. This problem doesn't take much time. If we observe it carefully, we can see it's a uniquely structured. One can give out the result right away without any paper or tool, if the essence of the problem is captured. Okay, let's give 2 minutes to try now. You can try to see if you can get the result with your calculation by brain or heart. Again, if you learned calculus before, you can have a quick result. Okay, 2 minutes is passed. How is your result? Hope all good. Let's move on. For those who are not able to come up with calculation result after 2 minutes, here is the final result. Looks neat, right? Not much complex at all. The key point is to understand this type of problem's characteristic, and surprisingly the solution approach and result is much simpler. Now, let's take a look at the steps for problem solving process. We know one important rule in calculus is the chain rule. We can apply it here. Let's introduce an intermediate variable u and define it be x squared. This approach is like using u to wrap x squared, so we can deal with u in process instead of x squared. Since u equals x squared, and both sides are differentiable, let's take derivative of both sides with respect to x. This doesn't change the nature of the relationship between u and x, right? This is just like any other math operation on same quantity applied to both sides of the equation. Often this leads to much simpler and manageable problem to tackle. Here we can see, the derivative of x squared with respect to x is equal to 2 times x, thus the differential u is equal to differential x squared, which is equal to 2 times x times differential x, so the differential u is equal to 2x times differential x. Is it right? Yes. If you have question on it, pause the video and think it over to see if it can be cleared out. You can see we apply the chain rule here, without mentioning it explicitly. Now we can replace u with x squared, so 2x times differential x equals to differential x squared. This leads to x times differential x is equal to fraction number of 1 over 2 times differential of x squared. You can pause to think it if it puzzles. It's quite normal when dealing with calculus chain rule. Each problem requires unique technique to approach. Think it and practice to study will help. Now let's go back to original given problem. For definite integral of x times e to the power of x squared from 0 to 1, group x and dx together, and replace them with 1/2 of dx squared, since fraction number of 1 over 2 is a constant, so it can be brought outside of integral sign. Now we have much simpler integration to deal with. Replace x squared with u, transact x value into u, that is, when x equals 0, u equals 0, when x equals 1, u equals 1. Now the integral calculation is carried out on e to the power of u with respect to u. Since e is a special number, that e to the power of u is itself with regard to u when integrated, thus carried out integration equals to 1 over 2 times e to the power of u with low limit value 0 and upper limit value 1, which is further equal to 1 over 2 times parenthesis of e to 1 minus e to 0, which leads to final result, fraction number of 1 over 2 times parenthesis of e minus 1. Here is final result shown one more time. As we mentioned in the beginning of this video, the final result for this integral calculus problem is quite neat and simple. Although we spend quite much time for problem solving process breakdown, the reality is many who learned calculus subject and grasped concept well can solve this integral calculus problem in minutes and effortlessly.